our homework, right? But we just changed the value of each component. So in the beginning we see that switch is that A. So and again it's at a state for a long time. So we know that the capacitor becomes what? The capacitor becomes open circuit. The two capacitors are open circuits. So because there's no branch to this part, and they are just part this part, but the capacitors are viewed as open circuits. There won't be no current. Right? There's no current, so here the overall voltage is 40. It's 40. So we think that before the starting point, V1 plus V2 is 40. But what is V1 and V2? We have to consider what a capacitor does. Yeah. Even if it doesn't have any current, it might store charge. For example, here we say here's plus Q, minus Q, plus Q, minus Q, right? There are current, there are charge stored on the two sides of a capacitor. But here we see that here is minus Q and here is plus Q. And I think that the current, so the charge has to be identical. So we see that because Q is equal to C times V, and Q is equal to C1 V1 is equal to C2 V2. So we can say that V1, the ratio of V1 to V2 is equal to the inverse of C1 to the inverse of C2. Okay, any questions? So here we see that V1 is 2, V2 is equal to 4 to 1. Because it's 1, 2, 4. The ratio is 1, 2, 4. So the inverse is 4 to 1. So we can see that the overall voltage is 40. So we see that V1 0 plus minus is 32, and V1, V2 is state. Any questions? So here we find its initial voltage, and again the way the switch is connected to point B. Of course, you can create a differential equation to find the final solution. But here we have a quick method. As we said, we can find the final part. We say that the final, because currently the two capacitors are connected to ADV voltage. And as at this part, again, after a long time, it becomes the two capacitors become open circuit again. So we can see that V1 at the final stage, V1 is equal to what? V1 is equal to 64 and V2 is equal to 16. Any questions? Do you know how to derive it directly? Because as we find, if the total voltage is 40, then because of voltage division, V1 is equal to 32 and V2 is equal to 8. Because it's inversely proportional to its capacitor, right? And when time approaches infinity, 当时间趋于正无限大的时候 time approaches infinity, again the two capacitor becomes open circuit. So here the overall voltage is again 80 volts. So again, the ratio is back to 4 to 1. Yeah. So we finally know its final value. So we have known its initial value and the final value. And what's left is time constant, right? So we have to find the time constant. The time constant is equal to R2. So after the switch, of course, further here R is equal to 6.25 K. And C, what is C? C is equal to what? Is it the complete combination? No, because the series connection of two capacitors will be what? Will be any questions? We know that the series of two capacitors is equal to the sum of their inverse and then inverse again, right? C1 plus C1 over C1 plus 1 over C2 is 1 over the overall capacitor. Any questions? So here we see that the equivalent capacitor is 1 and is 0.16. So it's 0.116. So I think it might be, but it is new, so it might be 1 over 1000. So here okay, so I think currently we have almost everything. V1 is equal to, as we say, final plus initial minus final initial. So for V1 it's 64 plus right. Any questions? For V2 E equal to 16. So the two items are correct. So we add V1 and V2 to the VO. Yeah, so the VO is also correct. Any questions? And finally, I is equal to C times the time derivative of V. So I think you can choose any one to find I. So for example, we see that VO is equal to 18 minus. So I is, and we said that the overall is times 40. Minus sign. So again, this solution, this item is correct. Any questions? And it's easy to find the energy trap in the capacitors when we use. Okay, any questions? 这些选项都是对的，是吗 ？Any questions? So let's get to okay. Before we finish chapter 7, are there any questions? I remember that last week you mentioned to the TA saying that you have 2 questions. And then of course we can follow the quick manner as we say that we have to, because here IO is passed through the inductor, so it's also IL. So we can use the quick method by finding I is equal plus right, and then find when the time approaches infinity, we find the three parameters 1, 2, and 3. Time constant is equal to L over R. Okay, so our objective to find the three parameters. Okay, in the beginning we say that when the switch is in A, the switch is in A, and again it's a long time, so the inductor is like a short circuit, right? Any questions? So here we would like to analyze the part of the circuit. So the part of the circuit becomes what? Here is of course we can use KCL. We assume that there's VO, so VO over 40 plus VO over 40 plus VO over 10, yeah. And here plus VO minus 80, so 800 over 120 is equal to 0. Any questions? Even though we would like to find I, but here maybe it's much easier to use terminal voltage or non-voltage VO as the direct variable. So here it become we time 120 and find 3 VO plus. So finally 16 VO is equal to 800. So VO is equal to 50. So here, before the switch change, we can see that VO is equal to 50. So we can see that the initial current is equal to 5. Any questions? Initial inductor equal to 5. So the next stage is to find I infinity. So this one. And when the switch is changed to B, what would happen? Again we can still use VO as the direct variable. Okay. And after very long time it becomes short again. So now VO over 40 plus VO over 10, the two branches. But there is another bridge, because here is also VO plus VO over 8. And here is the current and entering. So it's entering the node, so it's minus 50. Okay. Any questions? So we times 40 and VO plus 4 VO plus 5 VO is equal to, so 10 VO is equal to 2000 VOs to 200. So yeah, because it's 200, this branch will be 20. Okay. Any questions? And the next stage is to find time constant. The time constant is that we just have to consider what because the current becomes unopened. There is no current. We would like to from the view of the inductor, it is what? It is 10 ohm and 40 ohm. And this part has disappeared. So the overall R is equal to what? It's over to the parallel connection of the 40 and A plus 10. Any questions? Got the idea? Because let me double check. It's 8 ohm and it's 40 ohm and here is 10 ohm. So it's from the inductor. This is the overall resistor in this. So I think you have to find out your this. So I think it's easy to get tau. So finally you can get R is equal to final plus initial minus final times exponential to minus T over tau. Okay. Any questions? I think the other part are just numerical, so I don't familiar with that. 剩下都是数值运算，我们继续算。Any questions? Okay. I think we take a short break. We take a break of 10 minutes. And we will start chapter 8. We will have a quiz every 3 weeks, right? So we will have a quiz next week, and it will take about 1 hour and 30 minutes. 就下礼拜我们课堂有一个正式小考。
下一拜正式小考。
像我们说3个礼拜小考一次一样。我记得要可能是上课期，可是其前半个1个小时，前1个半小时，后1个半小时，到时候再决定。Okay. Here let's take a look at this question. This is a question raised by another student. Here we would like to find the capacitor voltage. So again, before the switch, turns to right, the initial condition. Like this formula. Any questions? Any questions? 有什么问题的？这应该相对容易的，这是 natural response。And here we would like to find I. So as long as you know VT, you can find IT. For example, ICT. You can see here it's minus IC. We see that IC is equal to C times the time derivative DC. So here you can find IC. So the direction here is the opposite. You can use minus IC and you can use current division. Here I is equal to because here it's 6. So here you can find I directly. Any questions? You can use current division. 用电流分流定理跟电阻成反比。Any questions?
照，为什么？
Any questions?
耳朵右边是有蜜蜂在你耳朵里，你耳鸣。
每个礼拜天都有在 Moodle 上面放那个问讨论区，但是好像你们都没有在上面写。
我都听不到。
你们去上学期不是还有在上面写？现在我好像没有。记得以后就直接放在上面，这样那个我也可以直接在那个 Moodle 上面回忆。但记得就是要在 TA 会规定一个时间，不能够说你到今天突然半夜才放上去，这样对，就是说这样那个解题会来不及解，对你没有什么帮助。因为最近学校在投票，说那个要正式改成那个。不过你们没有那个
改成什么？
你们有没有收到？要正式改成16周。
哦，16周。
要在投票。问卷。对。那大家赞成还是反对？大家都赞成。
他说16周，所以是18周改成16周。
就是可能缓冲了2周也没有。那当然。很多对老师，大部分老师可能会觉得，不在意的老师觉得很好，反正上多少就上多少，也不在乎。可是或许比较认真的学生就会觉得，什么受教权被影响。其实这些很多东西都是那个。当然就是有好处有坏处，就是说那个16周是有仿效国外的或是什么的台大什么，当然我也不是说台大学就多用功，
我也有听到，只是它不是来自于同只耳朵，它是我2只耳朵都听到，跟我右耳比较好。哦。
就是说，在国外的时候呢，事实上，他们通常老师只是 也不是随便讲，就讲点原理哦，这 detail 所以大家回去自己推导。
我两
就给一
边都
大堆题。
我头这样转是这边，
但如果
头这样转是这边。
你自己不做的话，都就是
我现在
被打
是有听到，然后这样像是这
就是
边。
这夸张一点，一些什么一些名校啊，Stanford、MIT 啊，每门科都是把学生当做这个学生只有修他的课，所以他一个礼拜全的时间都要做他的，都要研究他这门课。所以大家如果看美国影集，我大家有看美国影集，他们很多学员，你会觉得为什么那么弱？但虽然我在说回到实用中不是说不好，但是 component 就是元件的成分 ，capacitor, inductor, and resistor. But in chapter 7, we just consider the circuit about R and L or R and C. But this chapter we will consider the effect of combining the three parts together, which is RLC circuit. So yeah, we will focus on the behavior of a circuit which consists of 就是有什么结构 consists of or contains the circuit contains three components at the same time. Yeah, capacitor, resistor, and inductor. And sometimes they are connected in parallel, and sometimes they are connected in series. 就是串联或并联。And we have to consider the behavior, the behavior of branch current. We always consider the branch current or node voltage equations. But it is a little different from what we have learned in chapter 8. It will involve with second order differential equation. Second order, because currently they are both inductor and capacitor. Yeah. And when they are connected in series or in parallel, we will organize the second differential equation. And then of course there are still two types of response, which is natural response. The other one is step response. The natural response is the response after return of the connected source. Okay, so there's no longer source. There current source or voltage source that is connected to the circuit, and you have to analyze the behavior of the circuit. Like I just said, the branch current or the node voltage for the circuit. And step response is just the opposite. 就相反 the opposite. It's to consider the situation right after you connect the circuit with a voltage or a current source, a power, an energy source, or switch from one source to another source. Okay. But what's important is that the sources we are discussing are usually constant source or direct constant source, or we say is a direct current source. It means that VT and IT are both constant. And from the next chapter, from chapter 9, we'll talk about sinusoid current source or voltage source, which is alternating current. 直流就是 direct current。到这一章为止，我们还都在讨论那个直流，就是 DC。But from chapter 9, we will talk about alternating current source, which is 就是我们说的交流电。Okay. And of course, the current to differential equation. If we would like to find the exact, 就精确 exact final solution, we need initial conditions. Yeah, we need. But currently, because it is involved with the second order differential equation, we need two initial conditions. Because a second order differential equation will have two free constants, right? We'll have two free constants, and you need to use two initial conditions to determine the two free constants. 就是微分方，如果两界微分方程，它就有两个自由定值，对，就是未定的 constant， 还记得吗？那这时候你就要有两个初始值 two initial conditions to determine the two constants. And then we will see that the response for a second order differential equation of an RLC circuit will be three types, which is overdamping, underdamping, and then critical damping. The term damping is like decay. Yeah, it means the phenomenon to become small and small gradually. 慢慢衰减，这种 damping. But in Chinese, we use an interest and uncommon term which we call 阻力. I don't know why it is called 阻力. Maybe we just want it to be different from other similar terms. Overdamping is translated as 过阻力. Underdamping, I don't know how underdamping is translated. It's because over is the opposite of under, and the critical is 临界阻. But you just have to know that their Chinese translation is like this. And here that maybe before the introduction of before we finish the keyword introduction, we take a more look at the three conditions. In fact, the three conditions are simply related to the solutions, because it involved. Maybe here I will give you a quick review of second order differential equation. I think you remember even this is second order differential equation, right? It's a constant coefficient second order differential equation. right？ 在公数应该有学过。And the general method to find the homogeneous solution is to assume that y is equal to exponential to gamma t, right? So we replace to this equation, and you can find gamma squared plus a gamma plus c is 0 if we would like to find the homogeneous solution, right? Okay, so here we can say that here we have a polynomial of a second order, and we set it to 0, and here you can see that as you learn at junior high school, the solution or the root of this equation will have 3 different types. 2 distinct real roots, right? I mean the solution. Sorry, let me use a large area. Gamma squared plus a gamma plus c equal to 0. There are three types, and the first type is 2 distinct real roots， 就是2个就是相异时根 real distinct roots, and the type 2 is what? 2 yeah, it's also real roots, but it's identical real roots, 2 identical real roots. Okay. 就重根，但重根也是10根。Any questions? And the type 3 is what? Is complex roots. Complex roots. Two complex roots, but the 2 complex roots are completely conjugated to each other. Like gamma 1 is alpha plus j beta, and the other one is gamma 2 is equal to alpha minus j beta. So even if we have 2 complex roots, they are still connected to each other, which are conjugate to completely conjugate to each other. Any questions? So I think it's very basic. It's very easy for you to know that as for a single order differential equation, there are 3 types. And then we say that it will cause over damping. If the solution has 2 distinct real roots, then we will say that it's over damping. And if it's complex roots, we will see that it's under damping. But if it has 2 identical real roots, it will be critical damping. I'm not sure if you have learned the three dampings from differential equations, engineering mathematics. 在公数中学到 还是还没学到？公数已经讲到这个，好，现在不是公数下嘛？对我来说，那这不是公数上有讲到，还记得吗？
对，可以拍短片。
记得吗？好。Maybe we go a bit further to say that okay, if the truth, then let's say the two roots are gamma 1 and gamma 2, and for the first type, the solution is C1. Okay. Any questions? In fact, we use plus because in most cases gamma 1 and gamma 2 are negative. So it's type 1. Type 1 is overdamping, and it's maybe it's the most the simplest case. And for type 2, it will be like this. Because there is just one. In fact, there are two roots, but the two roots are identical. So we use just one gamma, but here we have two variables. We have two constants to determine, right? Determine 就决定的这个 determine. And as for the third case, it's complete roots. But the complete roots must have the form. So we see that the final one will be what? Of course, you can still follow this one, but we can further organize it as C exponential alpha t cosine beta t plus d. It's something like this one. So here the alpha and beta are here, but the two free constants c and d, and one is at the amplitude, and the other one is at the phase. Any questions? So it's all about mathematics, all about second order differential equations. Any questions? Okay. Before we take a break, let's see these common use terms: time derivative, changing rate, continuous, proportional to, inversely proportional to, absorb energy, release energy, coupling, discontinuous, and abrupt change. Maybe we have to be more focused on the term, because these terms are very often used. Proportional, inversely proportional. Okay. Or sometimes we say correlated. Positively correlating to 正相关 positive. It's not always proportional, but sometimes we say that when one increase the other one also increases, then we say that they are positively correlated. 它们是正相关的。Okay, so now let's go back to the content of chapter 8. RLC parallel connected circuits. And you will see that because it's a parallel connection, the common variable must be the current. Yeah. I mean the overall current had to be summed. 这三个电流必须要把它加在一起。Because it's the nature response, and there is I mean the circuit is no longer connected to other parts. So here is open. It open, so the overall current had to be 0. Okay. Any questions? Because here it is open. But yeah, from the two equations, you may see that okay, maybe it's 0, it's 0, it's 0. Okay, then we finish the solution. But it's not the case at the instantaneous situation. Maybe in the final stage, yeah, the current will be 0 terminal. But yeah, we would like to discuss the instantaneous 就瞬间的反应 or we say is temporal response. For example, if in the beginning, yeah, if in the beginning Vi is not equal to 0, then there must be IR, yeah, non-zero IR, and the other parts are not necessary 就是不总是，不一定是 necess necessary or not necessary 0. So we can create several equations. But in the beginning we have to write down the relationship between Vi is the relationship for the three components. For C, it's I is equal to C dV over dt, right? For L, so V is L di over dt, and for R, it's just Ohm's law, right? Any questions? Any questions? So, but now the common variable is what? The common variable is V. So here the three V's are the same, but the current are different. IC, IL, and IR. The three current variables are different. We would like to insert the three current into this equation. IC is equal to C times, because V is common. I mean V is common to the three. We don't write down its subscript. 就是我们不用把它下标记上去。So it's IC times, and IR is equal to V over R plus IL. Currently IL has to be the integral. It becomes an integral of V. So we create such an equation, right? It's not a differential equation because it includes the differential term and the integral term. So it's not really a differential equation. Okay. But here we can take another time derivative to get what? In order to cancel the integration, so it becomes this one. So we get a second order differential equation. Okay. Even though I have to say that the operation is not always correct, but here it's correct. But I would like to say that if the right part is non-zero, for example, here is not 0, here is not, for here is 5. Of course, when we do time derivative, the equation is still true, but the operation will cancel some possible solutions. So we have to be careful about this. 就是说，我们这样解呢，这只是一个偏义形式的做法，就再取微分一次，只是为了把积分拿掉。对。可事实上你会发现，那你会说，那如果就算这边不是等于0啊，那我们这边比方说这是个常数，你取微分不是还是等于这样子？那就分不出说这个求出来的解到底是原本等于0的解还是不等于0的解，对。但是我们这边至少它，等一下我们会再用一个比较严谨的方法来说，这只是帮助我们去解那个homogeneous solution。Okay, then let's take a 10-minute break. 我们先下课休息10分钟。Okay, we just took a look at the RLC circuit, parallel connection circuit, and again we see that for this circuit, the voltage is common to the three components. The voltage is common to the three components, but the current overcurrent is the addition, 相加 addition. Here let's take a look. Okay, so we just say that okay, VR is equal to VC equal to VL. We use a common variable V. The I is to be summed out. Because its natural response I is 0 and the I is equal to IR plus IL plus IC. Okay, so for this equation, we see that IR, because we would like to create this equation and change the variable to the common variable V. So we say that V over R plus IL, because IL is equal to T. So it involves integral equation instead of differential equation, right? IC is equal to C dt dV. So it becomes a bit strange. So I mean we take a simple way. We further take another time derivative, and we see that it becomes plus C d squared V over d squared is 0. I think this equation or this conversion is correct. Of course, it's correct, but it's not complete. 这样的转换是不完整 complete because if the right side has a non-zero constant, we will still make it disappear to be a 0. But what we are focused on the final equation, second order equation is this. RC plus sorry, let me double check that right. LC over V. So we create the homogeneous equation, this one. Equations. So we create the homogeneous equation for V. But I would like to say that if we take it more seriously, I just mean that the step is not very complete because we might cancel some possible solution. So here I would like to use another approach. Of course, we still say that IR plus I plus IC is 0, and here we say that V over R plus tau plus C is equal to 0. But because here is an integral, and we don't like it, so we say that IL is equal to L. So again, we see that V is equal to L di over dt. Okay. And then currently V is the common variable. But we change it to IL. I mean that we can insert V in this equation, and we can see that here we replace the variable V to IL. Because of the step, we don't cancel any possible solutions. So you can take a look at the equation. The second time derivative of IL plus RC plus let me double check those. So here we see. So here is still our right. Let me double check what's happening. So it's B. It's I see. Okay, here there is another error. Okay, so you can see that the differential equation for IL is this, and then if we use V, the differential equation is this, and the two are both homogeneous equations. Okay, and we can see that the parameter or the coefficients are the same. The coefficient is 1 over RC, 1 over LC. And here is also 1 over RC, so 1 over LC. 这我在讲什么？就是说，如果我们用原本，虽然这个看起来比较好，所谓比较好，就是说它是共用大家一起用的，因为大家共同的变数是 V， 对不对？因为并联的时候，电压3个电压的相同，3个电压都是相同，所以，但是这边我说会扯到一个问题，就是说，我们直接从这边取微分，其实这微分得到结果，这个公式是对的，但它可能会变成一个多对一的情况，因为我刚刚说这个，它右边不等于，如果就算不等于，它取微分还是会等于0，对，所以它可能会删掉原本可能的那个 particular solution， 但是这边我们用比较严谨的 比如说这个公式，那这个公式就只有微分没有积分嘛，我们就直接拿 IL 当做 variable， 那得到的结果，这个式子当然跟这个式子不一样，但是我说它前面的系数都一样，所以我们解的是同一个，那个 second order homogeneous equation， 对不对？我们只是用不同的变数解而已，没问题。So we still follow the procedure of the textbook. So here we still use this equation plus, but here you have to be familiar with the coefficients. Because in this chapter the two coefficients are very important. It's best for you to memorize it because it involves with the final solutions. And as we have reviewed, y double prime plus y prime plus ey. How can we solve the homogeneous equation? We will assume that y is equal to maybe a constant alpha t or gamma, anything is okay. And we insert it to this equation, and finally we can find it. Let me give a bit detail because y prime will be alpha c, and y double prime will be alpha squared c alpha t, and we put the 3 into the original equation, and we can find that alpha squared plus a alpha plus b alpha is 0, and there is a c here. Of course, we assume c is not 0, so finally we have to solve this with it's a second order polynomial, right? Any questions? I think you have learned from differential equations, right? So again, we see that we can assume that Vt is equal to V is equal to C exponential. Let me check. Okay, we use lambda t, and we can create such a second order equation, right? Okay, any questions? And as I just said, we have to discuss these 3 possible situations. So I mean there are three conditions. Okay, maybe we can directly go to the known part. You see the equation, and we can find the solution to this. 这应该大家都记得 ，2a 分之负 b 加 m 号 b 号 b 之类的事，应该大家还记得这个公式。So you can see that, okay, here the equation is a special term which is called characteristic function. So here lambda, here the parameter lambda or the variable lambda is equal to this one. And of course it can be simplified. And don't care about the names. You just have to discuss the possible values to divide it into 3 situations. So in the beginning, you have to remember that it's a solution is that this one, alpha squared minus omega 0 squared, and alpha is equal to 1 over 2rc, and omega 0 squared is equal to 1 over rc. And I have to say that the equation is very important. Omega squared is equal to 1 over LC. Because in later sections you will see that it's a resonant frequency. 共振频率，这最好把它背起来。这是为什么我们特别要用 omega 这个符号，就是那个 omega， 你会发现在 RLC 里面，这共振频率就是根号 LC 的1 over the square root of LC， 所以最好把这个公式把它背起来。It's called resonant frequency。虽然我现在是说你暂时不用管这些变数名称。So you have to see that there are 3 conditions. The first one is distinct real roots. 相异式的 distinct real roots. It happens when alpha squared is greater than omega 0 squared. Okay. And the second case is alpha 0 is smaller than omega squared. So the root might be the roots are complex conjugates, complex roots, but they are conjugate to each other, complex conjugates. And the specific case is it's called repeated roots, 重根 repeated roots. And of course, yeah, we will have here we just talk about the possible roots in section 8.1. Okay, maybe because we just have 20 minutes. We use now to summarize some important knowledge. So here's a simple example. Yeah. Okay, here you can say that if we insert the real variable R, L, and C, you can find these parameters alpha and omega 0. Here you can see that currently it's the first case alpha 0, so alpha squared is greater than omega 0 squared. So here this is over than because the two roots are minus 5,000 or minus 20,000. So yeah, you can organize that the final solution is in this way. But it will be discussed in the next section. 这个节知道到下一节才会讨论。这边只是那个我们简单看一下怎么样求出这三种情况。Okay. Here in the next some example it changes the resistance should be smaller or larger. Originally R is equal to 200, but currently it is changed to more than 300. So you can say that when we enlarge the area of the resistance, because currently alpha gets smaller because alpha is equal to 1 over 2 RC, and currently R is greater, so alpha is smaller. And when alpha is smaller, it will become the case alpha squared is smaller than omega 0 squared, or alpha squared is equal to omega 0 squared. So it might be critical damping or under damping. Okay, so in this case, we see that the frequency, the resonant frequency is still kept the same. So but alpha is smaller, so it becomes under damping. Any questions? So it becomes under damping, and it has two complex roots. And the next one we would like to see how much the value of R will determine the critical damping. So when critical damping happens, we say that alpha squared is equal to omega 0 squared. So here you can find that when R is equal to 250 ohm, we will have critical damping. Any questions? So I think it's just numerical calculation. 这边只是数值运算而已。Any questions? But here maybe we take about 2 or 3 minutes to talk about critical damping. Sorry, under damping. When we have two roots, for example, we just said we have two roots as alpha plus j beta and alpha equal to lambda is equal to alpha minus j beta. Then the original solution might be C1 explanation alpha plus j beta plus C2 explanation alpha. Okay, but you will see that the solution is a little ugly, and we just said it might be finally cosine beta t plus a plus k, something like that. We are more familiar with the form. But how it becomes this one? Okay. Because we have to notice that the solution is real. Even though here we see there's something imaginary happens. We still have to say that v is real. 解是10个，解是实数。虽然解出来的根是 complex， 但是我们要求它的 solution 是real。how to show that a variable is real? We just say that it is equal to its complex conjugate, right? So we say that when we take its, when we say that, okay, it's C1, and you have to notice that C1 and C2 is also complex conjugate. It's also complex, so in here is this C1 complex conjugate. 这我现在在干嘛？我现在就要证明说这个式实际上可以进化的这个式子。OK， 你 here you will see that alpha minus j beta t plus c2 exponential plus j beta t. And you know that the two terms are equal. The two terms are equal to each other. So you can double check with this one, and you can see that this term is equal to this term, and this term is equal to this term. Okay, why? Because the two items have to be equal. What's wrong with this? Okay, then, because we have to be quick, let me describe it in Chinese. 既然这两项要都相等，对不对？而且是针对每个时间点都相等，不是说只在某些时间点相等而已。所以你既然在所有 t 都相等的话，你看这边这一项有跟这一项相，所以我们就说这一项要完全等于这一项，这一项要完全等于这一项，没问题吧？因为你一个是正频，一个是正频率，一个是负频率，这两个你要让这两个它们有各自不同的参数的话，你要让它相等的话，只有这一项等于这一项等于这一项，有问题？这应该讯号系统你有上到这个，对不对？所以呢，你看这边就导出一个重要的结论是 C1 呢。如果这两项要像 C1 要等于 C2 的 complex conjugate， 问题，这最重要的就是要推出 C1 等于 C2 的 complex conjugate。那既然 C1 等于 C2， 那我们就规定 C1 就是好，那我们就说它是 C 的 exponential JC。那所以你看，如果 C1 等于 C 的 C 绝对值的，那 C2 就自然就是 C 的负的角度，因为共2嘛，对 ，C1 跟 C2 是互为共2，有没问题？没问题吧？好，那你看，我们再把它带回去 ，VT 等于 C1 就是 C 的某一个项角，然后 exponential alpha 加 J 的 beta t plus C 本身又是 C 处又是这是负的相角 ，exponential alpha minus j beta t。OK， 所以这边解答就出来了，因为当然你会发现说，这整项是这整项的共2，对不对？你会发现把这一项取共2，因为这是实数，不管这一项取共2是不是就等于这个？对，因为自己加自己的共2等于多少？自己加自己的共2等于2倍的什么？自己加自己的共2，这个等于2倍的 cosine， 对不对？还记得吗？2倍，自己加自己的共2是2倍的那个 real part 的实部，那自己的实部就是自己去乘以自己的绝对值乘以自己的相角的 cosine， 还记得吗？这应该这是公数还是有讲到，还是高三数学，所以你看这时候就变成什么 C 的什么 exponential， 这就把这个实部这绝对值的部分完全拿到这边 cosine beta t plus 相角，对。有问题，所以你看，这就是我们说的，为什么 solution 最后原本是要求 C1 跟 C2， 当然你也可以求 C1， 可是 C1 跟 C2 必须要在互为共2的前提之下。那你看，在 C1 跟 C2 互为共2前提之下，当我们决定出 alpha 跟 beta， 就是我刚刚说的这个共2复数根的实部跟虚部之后，剩下2个 free variable 就分别是在正负跟相角。对，问题 ？Any questions? Okay, so in section 8.1, we just talk about the three cases, and in 8.2 we will talk about the detailed solutions. So here you can see that, as we just said, yeah, if we have two distinct real roots, the general solution is then this one. But we have two free constants, a1 and a2, and the two constants have to be determined by two initial conditions, right? Two initial conditions. Okay, we discuss it later. We still double check the other two cases. Okay, if we have repeated roots, repeated roots, 如果我们重根的话 the solution is then this one. Any questions? If we just focus on the only solution, the single solution is not complete. It is supposed to have another solution. The solution is t times the condition as t. Any questions? 这些公式有学到吗？如果是复数，如果是重根的话，是不是另外一个根就把它乘上一个 t？ Any questions? And of course, it's independent. It's independent to the original solution. And we have to combine the two, so we still have two parameters, two constants to determine. And as for the overlapping, so it's case 1, case 2. Okay, so here we would like to talk about how to give initial conditions. I think you know about this one. We need to, for example, we assume that initial condition happens at time in 0. So we have to give v0 and v prime 0, right? 两个常数就需要有两个初始值，对不对？ So in general case, we give v0 and v prime 0. So you can see that if we give v0 and it will become a1 plus a2. And if we give v prime 0, then you can do the relative, it will become a1 as 1 plus a2 as 2. But how to get the two parameters or the two variables? It's back to our physical properties of RLC circuits. Again, we say that what is continuous? We always talk about the properties of C. We say that for capacitor, the voltage is continuous, right? Okay, so when we talk about natural response, it's a switch from on to off relative to the source, right? So we can use C. The capacitor voltage to determine its initial voltage, and the other is L. What is continuous for L? It's the current IL. Right? But because L, what's for L? The equation for L is I is equal to L times size. Yes, I guess I'm something wrong. Because we need to be prime 0. But for I, yeah, so I think it's still about C, not A. Which okay, maybe we start here. Any questions?
可以吗？
所以我们下礼拜的考试范围就考到8.1，但是到8.1跟8.2是相通的，就是它这边只在决定什么初始值，所以我们还是要这个，还是要看一下8.2的那个。